Probability refers to the likelihood of an event occurring, given that another event has already happened. It essentially measures the probability of one event happening based on the assumption that another event has already occurred and is calculated using the formula P. And there's going to be like open parentheses A and a straight line down. There's going to be B equals P open parentheses A, and there's like a long N, and there's like a B close parentheses slash P and a B inside parentheses, where P A slash B represents the probability of event A happening given that event B has already occurred. So P, A, and B is the probability of both events A and B happening simultaneously. And PB is the probability of event B happening alone.
Bayes' rule in logic is used to calculate the probability of a hypothesis being true with new evidence. It's basically allowing you to update your belief in a hypothesis based on observed data. It's kind of like reasoning backwards, but you do it to determine the likelihood of a cause based on the observed effect. So it is an important tool for using new information and refining beliefs when you're uncertain on the situation. Bayes' rule in logic is primarily used to solve problems where you need to calculate the probability of a cause given or probability of a cause with an observed effect. It allows you to update your beliefs about something based on new evidence and understand how likely a particular explanation is given the available information. It helps to invert conditional probabilities, which basically means that you can find the probability of a hypothesis with the observed data rather than just the probability of data given a hypothesis.
Bayes' rule is a powerful tool used to update the probability of a hypothesis based on new evidence. It addresses problems where we have an initial belief about a hypothesis called a prior probability and how we observe new data that could change our belief. So it combines three key components: the prior probability, the likelihood, and the marginal likelihood. Prior probability represents our initial belief. The likelihood is the probability of new evidence given that the hypothesis is true, and the marginal likelihood is the overall probability of observing the evidence, accounting for all possible hypotheses. Bayes' rule allows us to calculate for posterior probability, which is our updated belief about the hypothesis, and in abstract terms, Bayes' rule helps solve problems with conditional probability by providing a formal method for adjusting our expectations and decisions faced with new information. For example,
Howdy, my name is Simon Pedraza. This is problem 4, question 4 for the Field 240 extra credit Bayes rule assignment. Get started. To solve this problem, we use Bayes' rule, a method of finding conditional probabilities. First, let's define the relevant probabilities. P of S is equal to 0.3, P of O is equal to 0.5, P of T is equal to 0.2. These three represent the chances of Stardust, Okeer, and tasks handling the login. Next, P of CS is equal to 0.1, P of CO is equal to 0.03, P of CT is equal to 0.2. These three are the probabilities of a crash given each server. Next, we're going to look at the rule for Bayes' formula. The formula for Bayes' rule is P of SC is equal to P over P is equal to PCS times P of S over P of C. And then, as on the other slide, the total probability of crashing P of C is calculated using the law of total probability, which is P of C is equal to P of CS times P of S plus P of CO times P of O plus P of CT times P of T. Next, or I guess actually next, substituting the values for the total probability of the crash hitting will be P of C is equal to 0.1 times 0.3 plus 0.03 times 0.5 plus 0.2 times 0.2, which is equal to 0.85. Next, we'll look at the steps for Stardust, which is going to be P of SC equals to P of CS times P of S over P of C. Next, we want to substitute the values, which we get 0.1 times 0.3 over 0.085, which is going to equal to 0.3529. Similarly, the same steps for O here is going to start off with P of OC is equal to P of CO times P of O over PC, which again, substituting the values, we are going to get 0.03 times 0.5 over 0.085, which is going to be equal to 0.1765. So, in conclusion, there's a 35.29% chance Stardust handled your login and a 17.65% chance that it was Orchid. Bayes' rules like formula helps us to logically assign proposition based on our given confidentials. Thank you. And that is question 4.